Hello, my name is Nolan Beck, and I'm going to be showing a pathfinding algorithm with A-star. Unfortunately, I wasn't able to fully get obstacle avoidance and A-star to work well together, so this video is just for um, the 1 out of 2 points, basically, to show that I made some progress. So I was able to get A-star to plan a route there, no matter where I'm starting from, so it could be like anywhere around. But it gets stuck on walls, and I'm able to trace the path to where I want to go from anywhere. But again, because it gets stuck on walls, I basically just have to move the walls, or it won't go anywhere. So again, I'm just looking for the 1 out of 2 points, unfortunately. Alright, so here we go. Yeah, we can see, I'll demonstrate what goes wrong basically, but so we can see our target value is increasing in the heuristic. We know that there's a wall there. We're just not drawing it because that confuses things a little bit. But then it gets stuck on these walls like this because it just gets too close to them. But it will eventually get around, but it just is way too close to it. And I think it doesn't really make a whole lot of sense to keep going like this, so I think I might just move the wall for it. So what we'd see happen there is it can't actually get around the wall, so it just kind of like goes so close to them that it crashes and then gets stuck. But so it thinks because of where it got the LiDAR hits that the wall is still there. That's why it's kind of not going on a straight line path anymore to the goal. So like I said, we already saw this, so I'll just move stuff out of the way. And then in the next video, in the next demo, which I'll just do in this video, I'll show that it doesn't matter where I start from, it will get to the right location. It's just so see we got a LiDAR hit, so our route is changing a little bit. It takes a little while sometimes for the screen to update, but here's the replanning trace that we have. Updating now. We're just going over there. So I'll get all this stuff out of the way. Oops. Too much grip. Yeah. So again, just kind of going for the 1 out of 2 points here because I know I wasn't really able to get it so that it could stay far enough away from the wall. It just always gets a little too close before it plans its new algorithm to go around. Yeah, so that one hit a wall and is now going to try to update for it. It was too slow. Yeah, and there I hit a wall again, so now it's like, alright, give me away. You can see that by the desired heading. And the heuristic is 89, so that basically means there are 89 squares in however many walls we think there are, but because we don't have an idea of how many walls there are, it just means squares. Or, squares. Grid coordinates. So I think you would be able to get around this wall, actually, because it's going to know that it's there. But like I said, we don't draw the walls on here because... yeah, see, there it goes, trying to get around the wall. You can see, there we go. But now I'm going to move the wall out of the way. So yeah, there we could have successfully navigated around that wall, but I can't get around walls that are, meaningfully large. So a little less interesting to watch. Here we go, hitting the wall again. I'm just going to move it. I don't really care if it goes around. It's going to try to go around, I guess. But I'm annoyed by this failure, so I don't want to watch it anymore. Yeah, so here we can see we're kind of replanning to go on a curve to avoid walls. Shoot. I didn't mean to move that wall. Sorry. I'll be a little more careful there. Yeah, see, we're planning to get around the wall. I'll just move it for my guy's sake. And now it's having trouble because it's picking. So really, the source of the issue I can talk about a little bit is that I'm constantly running A star, and I don't. The occupancy grid sometimes gets a little screwed up when the bot is close to the wall, like what just happened right there. So then it has like it can't decide. The path isn't chosen quickly or correctly and consistently. For getting to the location, so it just kind of bobs back and forth between two paths, like one this way and one this way. And what that does, because of the slip in the treads, is make it so that I actually can't. I move forward a little bit instead of just perfectly in place because of the tread error. And so I inch closer and closer to the wall, and then eventually hit the wall. And once I'm stuck on the wall, I can't turn my treads to get off. So that's the source of this entire issue. It's kind of frustrating because without the tread error, it works perfectly. Just frustrating, but it's life. So I used an idea from the Homework 7 starter code, which I think was some other students' homework implementations for getting the current estimate, is that it always has to be within 1 point or 1 coordinate of the last place. That's why we don't see it change very often. And it's using a smoothing system that I think Sarah Coffin implemented. And I used in my code basically, but it just makes it a lot smoother, and there's not much slip in the estimates, so it doesn't really matter where I think I am. It just knows that it needs to go to a new location. So now, yeah, the heuristic says we are 25 locations away. Yeah, and the desired heading is any of the 8 directions immediately around the bot. So that's kind of cool. Again, I can't get around walls, so I'll just open the target right on up. So again, the path it plots is just the path right to the goal. So once we're at the path, the robot will stop. Once we're at the goal, not the path, we're obviously on the path. now I'm just choosing a location to go. Yeah, and so next, I probably will just keep this video going and show the homework 7 maze, because it's kind of the same thing. Great, yeah, and the reason it's just code here now is because it's done. Sorry if you heard that noise, it's my cat jumping on my computer. Alright, on to homework 6, which is the next maze to show. Alright, yeah, so this is not like going to be a meaningfully different demonstration, because obviously I just have to move the walls again or I'll get stuck. But first, I guess I'll just show going straight there, and then I'll kind of position the robot around and show that it can get there from any angle and not just straight on. It's not hard-coded or something. It's actually using A star. Yes, there's the path we're going to go on. Straight. Again, I'll spare everybody having to watch the robot struggle to get through the wall, because it's obviously not going to. So yeah, there it goes, changing a little bit, trying to get around, but again, it's the same issue that, like, I can't meaningfully get around. Okay, so I'll just move these. It still thinks the wall's there because it got occupancy grid hits on it, so it's just going to try to escape it basically and go around. And then once it sees that there are no points there, it will update. So I think what's happening is it's stuck a little bit. Yeah, there we go. Thank God. It was stuck in between 2 points. It's frustrating. Anyways, yeah. Now you're seeing why I have no prayer at the 2 out of 2 points. Just hoping for 1. So yeah, now it's updating its sensor data with kind of the idea that there are no walls around it. I guess I don't know if this is meaningful to watch. I'll record it just in case somebody wants to, while I move the stuff around, but I'll also include in the description timestamps of me kind of moving the robot to different locations and clearing the walls, and showing them, like, okay, it actually is using a star, and it can get around some walls, but it gets too close to many of them. So yeah, that was just it turning away from the wall hit. So the way the wall hits work is whenever I get a wall hit, the heuristic is that if you see a wall somewhere, each grid next to it gets a smaller wall hit. So it's just kind of a guess that if there's a wall, there probably walls near it. So even when we get wall hits like back here, somewhere that isn't on our path, it might affect somewhere that's in front of our path. So that's why you see some of these tiny corrections on wall hits that kind of shouldn't affect the path. If well, we would think won't affect the path. And again, like these wall hits should be fine. it would just kind of turn. But I think at this point it's clear that, okay, A star is running, the robot can align itself places, it can replan with A star, but it is boring to watch getting caught on walls, I think. It takes up a lot of time, so I won't subject anyone to that. Yeah, now we can see kind of some of the position error screwing us up. Like, we should be at 100, 100, and we're not really, because you can see that it's the origin, and thinks we're different. So we're off by like almost a full 2 points, I think it was. But it's okay as long as we're going to keep going until we get to the goal state. So as long as the error is consistently there, we'll kind of keep replanning to say, like, okay, even if we think we're at the goal state, which is 24,104, we'll reset our error, or we'll keep going, excuse me. So the way the surface clearing works is every 2 seconds. Every 2 seconds after replan, just sets up. So sometimes that makes for a little bit of like a weird view. But we can see that where we're trying to go is like up, 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 and then over. So again, I'll spare us. And then I'll show kind of like moving the, once we get to the goal state, I'll exit the program and rerun because the robot callback will stop. But I'll show that the robot actually can get to the goal location from other places. Alright, here we go. Should be turning pretty soon. There we go. Turn too fast. And the motivation for showing that it can get there from other places is that then you can see that I didn't hard code it to just go kind of like straight on. Yeah, so there it is in the goal, and I think the callback is going to stop. Yeah, just stopped. The path's still updating, but because that's in a different thread, that's it. So I'll end that real quickly. Move the robot like maybe over here and facing this way, and run brain. So yeah, now we can see we're just trying to get basically straight over, but we overturned, so it just replans to kind of go straight for a little while. And then I think after this, maybe I'll just move some walls and do one from up here, so I've kind of showed the from below. So yeah, it's still, so the occupancy grid isn't showing the hits on the wall, but that's on purpose, just because it kind of gets like really cluttered, and with the slip, it can sometimes overlay against the tread, or against the path, which is pretty annoying. Anyways, so almost done with this part, and then again I'll just rerun brain, but move the bot like up here or something to show that it can still do it from any location. Just the problem is the walls, unfortunately. Uh-oh, overturn. You got it, little buddy. Yeah, there he goes. Doesn't realize how close he is. Yeah, so we can see some of the, like, error in where we actually are is, like, it thinks I'm in 2500. And before it thought I was in, like, 2399 at the same position, basically. I think that's pretty much to be expected, but, get stuck on this wall. Sadly. Oops. So it's getting stuck on the wall there. So yeah, what's happening there is some of the sensor data, like I said, oh shoot, screws with how the wall works. Yeah, but now we're obviously in the goal file. The robot's callback is done, but the pathfinding updating is still happening, and so is the visualization. But I'll kill it real quick and just drag them to another location to kind of show that it can still work from anywhere, provided that there are no obstacles. Alright, so back we are. So yeah, I guess I didn't explain this, but the target heuristic is the point we're trying to, that we think we're going towards, and the heuristic value for it. I guess I could have made the go forward a little faster. Alright, but yeah, so to summarize all this, occupancy grid works, visualization works, tracing the path that we're going on works, following the path works if there are no obstacles, and A-star in general is working. It's just the combination of obstacle avoidance and A-star that doesn't work because of the way the slip is happening. I haven't really been able to find a way to account for that. Because of the tread slip, I get too close to the wall, and that means that I am not able to actually avoid the walls. So yeah, hopefully that is 1 out of 2 material. The gold standard for today. Alright, there we are. Well, we know where he's in the gold thread, but they don't. He might accidentally back out, I guess. This is going to be the same annoying process that we had to watch last time, just bouncing back and forth until it can finally get to the location it wants to be in. There it goes. Alright, and there the callback stopped for the robot, because we're just kind of drifting lazily, and we're trying to turn, but not. And yeah, that's that. Yeah, well, thank you for watching. Be merciful, please.